Your quiz tomorrow, sections 7.6 and 8.1. 10 questions. You have addition, subtraction, multiplication, rationalizing that denominator, finding the indicated powers for each complex number, finding the imaginary solutions, solving by factoring, and solving by completing the square. So, if we look at number 1, you have 2 plus 9i plus 3 minus 4i. Since there's the addition between these two, you can just get rid of the parentheses and combine like terms. And remember to put your answer in the form of a plus bi. So you're going to combine the 2 with the 3. That gives us 5. Then the 9i and the negative 4i give us positive 5i. So that's just 5 plus 5i. For number 2, you're given 3 minus 5i minus 5 plus 2i. You have subtraction between these two parentheses, so you do have to distribute that negative into the second set of parentheses. So you have 3 minus 5i minus 5 minus 2i. Remember, when you're distributing that negative into the second set of parentheses, you're changing the sign on each of the terms in that second set of parentheses. So from here, combine your like terms. Your 3 matches with the negative 5, which gives you negative 2. Your negative 5i matches with the negative 2i, which gives you negative 7i. So that's just negative 2 minus 7i. And remember, a plus bi form, which you have your constant minus your 7i, you're good. For number 3, you have 4 minus 3i times 2 plus 5i. You're going to FOIL this out because it's not a difference of squares, so you just do 4 times 2, which is 8. Then 4 times 5i is 20i. Negative 3i times 2 is negative 6i. Negative 3i times 5i is negative 15i squared. We can combine like terms with the 20i and the negative 6i. That gives us 8 plus 14i minus 15 times negative 1, because I squared is negative 1. You turn that negative 15 into a positive 15, because when you multiply it by a negative, it changes the sign, and then you combine like terms. Your like terms here are your 8 and your 15, so 8 plus 15 is 23. You put it in a plus bi form, that's 23 plus 14i. If we look at number 4, we have 6 plus 2i times 6 minus 2i. Now this one is a difference of squares, which means you can just use a squared minus b squared. If we do that, that's going to give us 6 squared minus 2i squared. The 6 squared is 36. The 2i to the second power is 4i squared. We said that 4i squared is going to turn into plus 4, because I squared is negative 1. So that's just 36 plus 4, which is 40. For number 5, you have 2 minus 5i over 3 plus 4i. To simplify this, you're going to multiply the top and the bottom by the conjugate of your denominator. So that's that 3 minus 4i. I would put parentheses around both your numerator and your denominator and FOIL it out. You can also use your difference of squares for the bottom. So this is going to give you 6 minus 8i minus 15i plus 20i squared, all over 3 squared is 9 minus 4i squared is 16i squared. Up top, you can combine your like terms. So it's going to give you 6 minus 23i plus 20 times I squared is 20 times negative 1, which is negative 20, all over 9 plus 16, because again, that I squared on the 16 is negative 1 times negative 16, which is positive 16. So you combine your like terms, and you're left with negative 14 minus 23i all over 25. You do not have any common factors that you can simplify all of your 3 terms by, so you leave it just like this. For number 6, you have 3 plus I over 2 minus I. So again, we're going to put parentheses around the numerator and the denominator here. Multiply top and bottom by 2 plus I, since that's your conjugate of your denominator. If you FOIL out on the top, that's going to give you 6 plus 3I plus 2I plus I squared, all over. The bottom is a difference of squares, so that's going to be 2 squared, which is 4, minus I squared, which is I squared. Simplify from here. Your like terms up top give you 6 plus 5I minus 1, because I squared is negative 1, all over 4 minus negative 1. On the denominator, your 4 minus negative 1 turns into 4 plus 1. Up top, you combine your like terms, so you have 5 plus 5I all over 5. All 3 terms that you have here are divisible by 5. So your 5's all become 1s, and this is just 1 plus I. For number 7 through 10, it tells you to find the indicated powers of each complex number. If you remember with these, you are going to use that chart. We said that chart looks like a coordinate plane. The top, you're going to have 0.0 or something 0.0. That's going to be 1. To the right, it would be 0.25, and that would be I. On the bottom, it would be 0.5, and that would be negative 1. And to the left, that would be 0.75, and that would be negative I. So remember with these, you are taking the power, you are dividing it by 4. Whatever decimal value you get when you divide that power by 4, you are then going to use your chart and turn that I to whatever power into either 1, I, negative 1, or negative I. For number 7, you have negative 3I to the second power. This is the same exact thing as saying 9I squared. So if we divide that power of 2 by 4, it's 0.5 or 1/2. So that I squared is going to turn into what? If we look at our table or our chart, that 0.5 is negative 1. So that's just 9 times negative 1, which gives us negative 9. For number 8, we have 2I to the 5th power. That 2 to the 5th power is 32. And then we have I to the 5th power. So again, we're going to divide that power by 4. That gives us 1.25. So we look at our chart, the 0.25 is I. So I to the 5th power is just I. So that's going to be 32 times I, so 32I. For number 9, we have I to the power of 22. So if we divide the 22 by 4, that gives us 5 and 2 left over. So 5 and 2/4 is 5.5. On our chart, that 0.5 represents negative 1. So that I to the power of 22 is just negative 1. And for 10, we have I to the power of 19. If we divide the 19 by 4, that gives us 4 with 3 left over. So that's 4.75. The 0.75 on our chart represents negative 1. So that I to the power of 19 is just negative 1. Or sorry, negative I. Not negative 1, negative I. Oops. For the next set of questions, we're just finding the solutions for these. Some of them you are going to have imaginary solutions in the fact of a negative underneath the radical. That's the square root. Remember, to represent that negative, you represent it with an I. And if you're taking the square root of both sides, you put the plus or minus in front of your answer. If we look at 11, you have x squared is equal to negative 72. To get x instead of x squared, we're going to take the square root of both sides. We do have that negative underneath the radical, so we'll represent that with an I. And then that 72 can factor to be 9 and 8. 9 is 3 and 3. 8 is 4 and 2. 4 is 2 and 2. So you have 2 2's that pair up. You have 2 3's that pair up. Multiply them. That's 6. The 2 that's left over stays underneath the square root. So this is going to give us x is equal to plus or minus 6i square root 2. For number 12, you have 3x squared plus 27 is equal to 0. You're going to start this by subtracting the 27 from each side. That gives you 3x squared is equal to negative 27. From there, divide each side by the 3, and that leaves you with x squared is equal to negative 9. If you take the square root of both sides here, the square root of 9 is 3, so x is equal to plus or minus 3i. For 13, you have 4x squared is equal to negative 9. For this one, you're just going to divide each side by the 4. We have x squared is equal to negative 9 over 4. You're then going to take the square root of both sides, and you get that x is equal to plus or minus 3 over 2i. All right, so your next section that you're going over, it tells you to solve each equation by factoring. However, tomorrow on your quiz, you are going to have a question that you are solving by factoring, and you are going to have a question that you are solving using the completing the square method. So if we look at number 14 and use the completing the square method for this one, we are going to, hold on, let me just rewrite this. X squared minus 4x minus 32 is equal to 0. We're going to first move your constant over by adding it to both sides. This gives us x squared minus 4x is equal to 32. In order to find your new c term, you're going to take your b term, which is that negative 4, divide it by 2, and square it. That gives you negative 2 squared, which is 4. Once you get your new c term, you're going to add it to both sides of that equal sign. So that's going to give you x squared minus 4x plus 4 is equal to 32 plus 4. You will factor the left side, add the right side. That gives you x minus 2 squared is equal to 36. From here, take the square root of both sides. If you take the square root of the left side, you have x minus 2. If you take the square root of the 36, you put the plus or minus in front of your answer, and that is 6. From here, you're going to separate this into two equations. One that is your x minus 2 is equal to negative 6, and one that's x minus 2 is equal to positive 6. And then you solve them both. For the x minus 2 is equal to negative 6, add your 2 over. That gives you x is equal to negative 4. For the x minus 2 is equal to 6, add your 2 over, and that gives you that x is 8. So you have two solutions here, the negative 4 and the 8. If we look at 15, 15 is a little different. We have 6x squared minus 5x plus 1 is equal to 0. If we solve this using the completing the square method, we're going to move the 1 over by subtracting it from both sides. This gives us 6x squared minus 5x is equal to negative 1. From here, we would divide each side by the 6 because you need an a, that's 1. So that's going to give you x squared minus 5 over 6x is equal to negative 1/6. If we take our b term, which is the negative 5/6, and we square it, divide it by 2, and then square it, it turns into negative 5 over 6, negative 5 over 6, not negative 5 over 2. Negative 5 over 6 times 1 over 2 squared, which is negative 5 over 12 squared, and that's 25 over 144. We're going to add that 25 over 144 to both sides of our equation. So that's going to give us x squared minus 5 over 6x plus 25 over 144 is equal to negative 1 over 6 plus 25 over 144. The 6 and the 144 you can multiply the 6 by 24 in order to make it 144. So this would become negative 24 over 144 plus 25 over 144. So we are going to factor the left side, add the right side. The part that was being squared to get the 25 over 144 is at negative 5 over 12. So that gives you x minus 5 over 12 squared is equal to negative 24 plus 25 is 1 over 144. If we take the square root of both sides from here, we're going to be left with x minus 5 over 12 is equal to plus or minus 1 over 12. So we're going to separate this into two equations. We have x minus 5/12 is equal to negative 1/12, and x minus 5/12 is equal to positive 1/12. We're going to move the 5/12 over on both of these equations by adding it to both sides, and we're going to be left with x is equal to 4/12, which simplifies to be 1 over 3. We do the same with the other one, and we're left with x is equal to 6/12, which is 1/2. So 1/3 and 1/2 are your two solutions here. If we take a look at 16, we have x squared is equal to 16 over 25. For this one, the only thing we have to do is take the square root of both sides, and we get that x is equal to plus or minus 4/5. For 17, we have w plus 3 squared is equal to 6. For this one, in order to find what w is, we are going to take the square root of both sides, and this is going to leave us with w plus 3 is equal to plus or minus the square root of 6. Because you can't simplify the radical of 6 or the square root of 6, you leave it as the square root of 6. From here, again, we're solving for w. We move the 3 over by subtracting it from both sides. It is not a like term to the square root of 6, so that's just w is equal to negative 3 plus or minus the square root of 6. For our next example, 18, we have x squared minus 4x is equal to 1. For this one, our constant is already on its own side, so the only thing we have to do is find our new c term in order to add it to both sides of the equation. Our b term right now is negative 4, so to find c, we're going to do negative 4 over 2 squared, which is negative 2 squared, and that is 4. So that 4 gets added to both sides of your equal sign to give you x squared minus 4x plus 4 is equal to 1 plus 4. We're going to factor the left side, add the right side. This gives you x minus 2 squared is equal to 5. We're going to take the square root of both sides, and that's x minus 2 is equal to plus or minus the square root of 5. Move your 2 over, add it to both sides, and you have that x is equal to 2 plus or minus the square root of 5. For your last question on here, for number 19, you have 2x squared plus x is equal to 1. Again, we're going to solve this using the completing the square method. Because our a is something other than 1, we're going to divide each side by 2 to get x squared plus 1/2 x is equal to 1/2. We're going to take b, in order to find c, we're going to take b, which is 1/2, divide it by 2, or 2 over 1, and square it. This turns into 1/2 times 1/2 squared, which is 1/4 squared, and that's 1 over 16. We add that 1 over 16 to both sides of that equal sign, so we have x squared plus 1/2 x plus 1 over 16 is equal to 1/2 plus 1/16. We write a like fraction to that 1/16 with that 1/2, so it becomes 16 over 32, 8 over 16 plus 1 over 16. We're going to factor the left side to be x plus 1/4 squared. Add the right side to be 9 over 16. We take the square root of both sides, and we're left with x plus 1/4 is equal to plus or minus 3 over 4. I'm going to separate this into two equations. I'm going to have x plus 1/4 is equal to negative 3/4, as well as x plus 1/4 is equal to positive 3/4. We move the 1/4 over by subtracting it from both sides. This is going to give us x is equal to negative 4 over 4, which is x is equal to negative 1. We also are going to have, minus 1/4. X is equal to 2/4, which is just 1/2.